The wind is blowing at 10 miles per hour, south 60 degrees east. So we're going to make that into a vector. And that's the lesson, the last part of the lesson 6.6. Danger of kids being a little too loud outside. I guess I'll leave that here rather than have it break. Okay, back to this problem. What we're going to do is make this a vector, and we're going to use this formula. The vector is going to be equal to the magnitude times the cosine of the angle I plus the magnitude sine of the angle J. That will give us the basic form of AI minus BJ, essentially. So the vector, or X, I guess we have an X and Y with it. So what we need is we need the magnitude and we need the angle. So first, the magnitude, we think of the magnitude as distance, but it's more than that. It's a little bit different than just a distance. What it is, in a problem like this, we have a direction that we're going, and this that we would normally think of as speed is considered to be the magnitude for this kind of a problem. So it's simply 10. So the magnitude will be 10. The angle, now, so that's the first thing we have to figure out. The angle that we need is not 60 degrees. Because when you have an angle, we're measuring from 0. We're not measuring from south. And south 60 degrees east means coming this way 60 degrees. So if we come 60 degrees that way, what we're getting in reality is a reference angle of 30 degrees, or negative 30. Well, it's really 30-degree reference angle. But the kind of angle that we need for this is supposed to be the normal format of coming around this way to that point. So 60 degrees east from south means 270 plus 60. Right? So that's a 330-degree angle. So what that really is cosine 330 degree I plus 10 sine of 330 degrees J. So actually, I didn't quite make a mistake. I just jumped the gun here. That magnitude is 10. The angle we see is 330 degrees. So what I just wrote here is what I should be writing down here. So let's do that. Let's do 10 cosine 330 degrees I plus 10 sine 330 degrees J. And now we can use the actual cosine and sine to get the numbers for that. So at 330 degrees, the cosine is square root of 3 over 2. And the sine is going to be a negative, and it's negative 1/2. So thus, we'll just sort of cancel that out and get 5. Cancel that out and get 5, and it's negative 5. So we have 5 root 3I minus 5j. So the vector is equal to that sort of mess, but once you figure out what the cosine and sine is, you get this vector, 5 root 3I minus 5j. So let's review what I did on this one here. The wind is blowing at a certain speed, that's your magnitude. You take the angle amount and you make sure that you follow around where it is so you get it from 0, okay, not from the 60 degrees or not the reference angle, but rather the 330 coming around from 0. And then you use cosine and sine to fill out those parts and multiply by 10. Not that hard of a thing to remember to do. But you will see this again. Well, actually, you'll see just about everything I do in class again, so make sure you're comfortable with doing that. That means your job for this one, more than anything else, is to recognize that you get the vector by using that formula. That's the all it really is doing the vector in terms of its magnitude and the angle. Okay. All right. Now, if there's time, I'll come back and do a practice problem. But actually, there's a bigger problem that we're going to do. I'm going to set this one up here. So I'm going to ask you to copy this out. The magnitude and direction exerted by two tugboats towing a ship are 4,200 pounds north 65 degrees east and 3,000 pounds south 58 degrees east. We are going to find the magnitude, that's a V, to the nearest pound, and the direction angle to the nearest tenth of a degree. So we'll do that, finish writing it out, and I will go through the steps of that in just a moment. Hey guys, I've got a little loud before, so make sure you keep it down. So there's no talking at all while we have classes with you, okay? None at all. My little seventh graders need some reminders sometimes. There's a sixth and seventh grade out there. Sorry, I should have made that a little bit larger there. So, the scenario here, let's think about what it is. And for me, I'm going to use like a couple of pieces of paper, but I want to sort of draw out here a little bit of what's happening. So, this kind of thing is sort of, understandable. You have two tugboats towing a ship that had problems with engines or whatever. Usually you have one, but if you have two because it's really big, they can do that. So here, north is here at 65 degrees, means coming down this way. North, south, east. So 65 degrees coming down here means we're going to have 25 degrees going that way. And this one is pulling it, this tugboat's pulling it at 4,200 pounds. The other one was south 58 degrees east, so that means we're 58, that leaves 88, 32 degrees. So let's say we go here, this is 32 degrees, pulling it at 3,000 pounds. So these two tugboats are pulling like that, okay? And they're going straight like this, but because they're pulling the ship, they're diagonal like this, so that's the degree they're pulling at. This one's pulling a lot more. So even though that's 25 degrees, what's going to happen is the ship is coming like this, and the ship is actually going to end up moving a little bit over that way, because one of them's pulling a little more. What we have to do is the actual direction, whatever the ship is here, we need to get the degree for that. That's going to be this degree. And we're going to have to get how much total pull is being exerted on it. It's not simply adding up 4,200 and 3,000, because some of that's being wasted by the ships being a little bit to the side. We have to get the actual number that it is. It's not just adding those to get together, and it's not getting the distance. It's not simply the difference between these two, because these numbers are not the same. If it was just the difference between those two angles, it would be down here somewhere. But the extra pull of this is changing that. So the way we figure that out is we're going to find the force that this one's exerting and the force this one's exerting, and we'll add those two forces. But the formula for the force is essentially making it a vector. So We're going to call this one tugboat 1. So tug 1, and this one's tug 2. So the force of the first one is going to be 4,200. That's the magnitude. In fact, that's part of the thing to find. See, this is going to be the magnitude. This one's the direction, but we had to get that actual number. Now, that's where we'll have to play with this a little bit, because this one is 4,200. We see that's 25 degrees, so it's cosine 25 degrees I, plus the same 4,200 magnitude, sine of 25 degrees J. That's similar to the last problem we did, there, where this force is the magnitude times the cosine of the angle I and magnitude sine of the angle J. That's what we just did. That one was easier because we could just use the 25 degrees. We're going to do the same thing with the second one. So it's going to be 3,000 and 3,000 and cosine and sine and I and J, but it won't be 32 degrees because we have to come all the way around here to that. So what it is, this was 58 degrees, so we have to do 270 plus 58. Okay, so that tells me that's what, 328? Does that work right? That looks right. So it's 328 degrees I and 328 degrees J. This is one of the places that people get sort of mixed up. What in the world am I doing? What number do I put here? So this is one of the things to remember. So sort of one of your checkpoints to make sure, oops, this is something I'm doing right or wrong. So all of these kinds of problems have some little thing that is easy to mix or mess up if you're not careful about it. That's probably one of the main ones for this. So now that we have those two forces, what we're going to do is we're going to be able to combine them. Right? And so in this case, oh, actually, we can't combine them yet. What we have to do is we have to actually calculate these out. So force 1, and I actually should have probably done that one first, so I'll do it now. Force 1 comes to, if you do the cosine of 25 degrees, and this is where you'd have no choice but to do it with a decimal. If you do the cosine, oh, I'm not sure what mode I'm in here. Okay, I'm in degrees and I'm not in function form, so I'm going to change it to that. Okay, so if I do cosine of 25 and I multiply that to 4,200, I get 3806. 3806.49. I'm going to round it up to, we'll round it down in this case, almost right in the middle. But it's 3806 pi. So cosine 25 times 4,200 is 3806. And on the other one, 4,200 times the sine of 25 comes to 1775J. This one, I'll do the same thing with, force 2. And I've already multiplied these out, so I'll tell you what they come to. This one comes to 2544I. And this one, it's not plus, it's minus. Because now this is where the sine of 328, we're in the quadrant where sine is negative. So this one is actually minus 1589J. So you see, the whole thing depends upon what angles you have and recognizing that you have the cosine theta I plus the magnitude sine theta J. So knowing that that's what the vector is, allows you to plug in the magnitude and plug in the angles, and now we get to this. So what we do with that, if you still have room, just stay on your page, but I'm running out of room and I want to write big, so I'm going to continue here on another page. I'm going to use those two forces, force 1 and force 2, and I'm going to be adding them up, but first I'm going to rewrite them for myself. So hang on for a moment while I do that. Whoops, that's 1775J. Always worth checking numbers again. So now we're going to make a force 3. The force 3, which is the force for the ship, is going to be adding these two up. And so force 3 is force 1 plus force 2. And one of the other lessons earlier is about simply adding these together. All you have to do is just add the i's and add the j's. So what we're going to get for force 3 is adding these together gives us 6350, I believe. 6350i. And here it's going to be this one, take away that one. Ooh, no, I didn't round right. That should have been 1590, but it's close enough for this. So I'm going to do 1775, take away 1589 is 186. So that's plus 186j. Okay? Well, now let's think about what we're going to do with this. Okay? Now that we have this, what we need is the angle for it. Okay? So what we're going to do, we're going to need the we need cosine of theta. What we're going to do, here's the things that A over the force, B over the force. So we can find out what the angle is by using these formulas, where the cosine of theta would be this number, oh yes, divided by the entire thing, okay? I'm getting specific. Oh no, this is the magnitude of the whole thing. Whoops, I'm getting myself mixed up. I need more space. Okay. So the magnitude of this, we have A and B here, so that means we're doing the square of those. 6350 squared plus 186 squared. So remember, the magnitude is going to be the square, what is it, the A squared plus the B squared. So what that comes to, the magnitude of this one, comes to 6353. Okay. Which is the square root of 6353, right? Yep, square root of 60. So, oh no, not because of the squares. You're squaring that, and you're squaring that, and that's so much smaller than this. And I shouldn't write it with the square root. 6353. That one's so much smaller than this that once you square this and you add that even squared, that's a little bit comparatively. When you take the square root of it, you're really only going a little bit farther up. Not very much. But now we have the amount that would go under here, or under this one. So you can either do 186 divided by 6353, or 6350 divided by 6353. I'll do that one just because it's first there. The cosine of theta is 6350 over 6353. And what that's going to come to is approximately 2 degrees. And I'm going to do second function, cosine of 6350 divided by 6353. 1.76. So it's just under 2 degrees. Very small. Okay, I could round that to like 1.8 degrees. I think rounding it to 2 degrees is going to be okay here. Oops, not 20, 2 degrees. So that's about 2 degrees. Okay, so what we know now, we've got the magnitude of this, and we've got the 2 degrees here. So what that enables us to do is to put these together. Where did I get my final ones? Oh, no, I have to. What we know now, back to this circle, is we had one of them pulling that way and one of them pulling this way, and where the ship is actually being pulled to is about 2 degrees here, and it has a magnitude of 6353. So back to the original question. Find the magnitude of the vector for the new one, for this, to the nearest pound. So the answer to that is 6,353 pounds of force. So there's that much force being exerted on the ship. and the direction angle to the nearest tenth of a degree. Well, now that's 2 degrees, but when you think about what's happening, or 1.8 degrees if you want to be more precise, but really the direction for anything nautical is always done north in either east or west, or from the south. That's towards the north, so we have to have this angle. So this is actually 88 degrees, or 88.2 if you want to get that specific. So reality is it's north 88 degrees east. So over here, the direction angle is north, and now I see that it says to the nearest tenth of a degree. So back here, you see that when it was 1.76, I should call it 1.8 degrees, and that means this would be 88.2. So following directions, I would make sure that I do that 88.2 degrees east. Okay, now let me go through those steps again so you see what to do. And what it actually is telling you is that this ship is getting that much more power on it, or that much more force. 4,200 and 3,000 is 7,200. Well, this is a lot less than that because some of that force is not being exerted fully on the ship because they are pulling apart as well. It's still a much larger than just one of the tugboats alone. So the 2 of them together are doing more work than just one alone. And then the direction that it's going is north 88.2 degrees east. So they're keeping pretty close to going almost due east. And remember, the way we figure it out is you take one tugboat's information and you turn it into a vector and calculate it with the actual cosine and sine to get the 3806 and 1775. You do it with the other tugboat, and then you can add those together to get the force for the to get the vertex for the ship. But you have to use cosine or sine and the magnitude in order to get the actual pounds and the actual angle. There's a number of steps to it. If I count them, there's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I'd say there's 8 different steps to it. Each one of these has like its own lesson, so it's really putting a lot of this stuff together. Yes?
In order to find the angle, would it be acceptable to use tangent of B over A? The textbook showed that at one point.
Yeah, I don't see why not. Yeah, it would be perfectly good. I'm used to doing cosine and sine. The example for this problem is cosine and sine, but I see no reason at all that you couldn't use tangent tips. That should probably work. In that case, we would have 186 over 6350, y over x. So I think that should work too. That should be fine. Okay, so that's a good question. Any others about this? Okay. So I'm going to just identify for this the step 1, step 2. This would be like 3 and 4. And then adding them together is the 5th step. This is the 6th step, getting that. And then the 7th step using cosine. But then the 8th step would be getting the actual degree like that. So doing that 6 gives you the pounds. So it looks to me like there's 8 distinct steps in this. They do make sense when you think about it. You're turning the 2 tugboats amounts into vectors. You're going further with that to actually get the simplified form of them. Then you are adding them together, and then you're using that information to get the angle and to get the pounds, doing the magnitude and cosine or sine or tangent.